In this video, we will use concepts of center of mass, okay, to find the mass of the certain person here. So the problem here is that there is a boat here, okay. It's located close to a pier, and let's say it's at a distance L from the pier, right? And there is a man um, with mass of 80 kilograms sitting at one end of the boat, and there's a girl, okay, whose mass is yet to be determined, sitting at the other end of the boat. And the length of the boat is about 3 meters, right? So when the man and the girl exchange positions, so that is the man goes here, the girl goes there, okay, the boat moves by 40 centimeters, that is 0.4 meters, okay. So we have to use this information to find the mass of the girl. Okay. So the thing is, we want to first understand why the boat moves in the first place. Okay, the boat moves because the position of the center of mass does not change. Okay, it does not change. So therefore, if this person is moving, this person who has a higher mass is located farther away. Okay, the boat moves closer to compensate for the change in position. Okay, and the center of mass, remains in the same position because there are no external forces acting on the boat and the people in the boat. Okay, so let's assume that the person is at, initially the man is at a distance L from the pier. Okay, so so, uh, so the position of the center of mass is essentially uh, 80 times L plus uh, L plus 1.5 times 30, because 30 is the weight of the boat. Okay, mass of the boat is 30 kilograms. Okay, okay, plus L plus 3 times M is the mass of the girl, and that's to be divided by 80 plus 30 plus M. Okay, so that's the position of the center of mass. Okay, and after the the man and the girl, they exchange positions. Okay, the new position of the center of mass is essentially computed as uh, so the girl comes to the left, so you multiply M by L minus 0.4, right? And so and we multiply 30, that the mass of the boat, by L plus half the length of the boat, okay, minus 0.4, okay, plus uh, the contribution from the man, that's L plus 3 minus 0.4, right, times 80 divided by 80 plus 30 plus M. Okay, so there is that. So when we equate the two, okay, so we get 80L plus 30L plus 30 times 1.5 plus ML plus 3M equals ML minus 0.4 M plus 30L plus 1.5 times 30 minus 30 times 0.4 plus 80L plus 80 times 3 minus 0.4, right? So what are the things that we can cancel? So the 80L cancels out, the 30L cancels out, 30 times 1.5 cancels out, right? And the ml cancels out. So all the terms that include l, the term that we don't know, they get cancelled out. Okay, so when we rearrange, so what we do is that we bring this here. Okay, so we get 3.4 times m equals 80 times 3 minus 0.4 minus 30 times 0.4. Okay, so m equals 80 times 2.6 minus 30 times 0.4 divided by 3.4, and that gives you approximately 58 kilograms, which is the weight of the girl. Okay, so here, so let's look at it a little bit uh, you know differently. So here we can write this as 80 times 3 was the length of the boat, okay, minus the distance moved by the boat, right, minus 30 times distance moved by the boat divided by L plus x. Okay, where x is the equal 0.4 is distance moved by the boat by the boat. So let's do this. So just to avoid confusion, let's write this as y. Okay, so just avoid some confusion because I've written x up here. Okay, so now, so that's the interesting thing that to observe. Okay, so so here, uh, see what happens here is that we can solve this problem in a slightly different way. Okay, so we know that, okay, so if uh, so so when the man here, okay, moves to the other end and the girl moves here, so the center of mass moves from one side of the boat to the other side. Okay, so from one side of the boat to the other side. Okay, so as I have shown, initially the center of mass was to the left of the center of the boat. After the man has moved over, okay, the center of mass has moved to the other side. Okay, so the total distance moved by the center of mass is 2x. Okay, now 2x, okay, is the distance moved by the center of mass, and that is the distance that the boat moves in the other direction to compensate. Okay, so that's the thing. So here 2x equals 0.4, therefore x equals 0.2. And so if we were to do the center of mass computation, okay, so 80 times L divided by 2 minus x, right? So because, okay, so let's not call this L, so let's say this is the length of the boat, and let's call that D, right? And so we write this as D divided by 2 minus x, because the distance of the person from the center of mass is this is D divided by 2, and this is x, so this distance happens to be D divided by 2 minus x. Okay, so that equals, so the weight of the boat acts through the center, so x times 30. Okay, so that equals 30 times x, right? Okay, plus the mass of the girl, okay, times L divided by 2 plus x. Okay, so here, so now all we do here is or d divided by 2 plus x. Okay, so what we do here is that we rearrange this to find m equals d times is 80 times d divided by 2 minus x divided by 30x plus or minus 30x divided by d divided by 2 plus x. And so we multiply both sides, the numerator by 2 and denominator by 2. So we get 80 times d minus 2x, okay, minus 30 times 2x divided by d plus 2x. And as I mentioned earlier, d times 2x equals y. Okay, so we can write this as 80 times d minus y minus 30 times y divided by d plus y. Okay, so that's exactly what we had before. So let me correct these things, okay, to call this d. Okay, so let me recap the solution. So we could do this two ways. Okay, so one is that we find the position of the center of mass before. Okay, so when the man is assumed to be at this end, okay, we find the position of the center of mass as 80 times L plus um, the contribution from the from the mass of the boat and the contribution of mass of the girl, okay, divided by total mass. Okay, and after the man has moved over here, we get the contribution of the girl plus the contribution of the boat plus the contribution of the man. Okay, and remembering that the boat has moved by 40 centimeters in the towards the pier. Okay, when we equate the two, we can just cancel out the denominators. Okay, and we expand each side on the top. Okay, and we find that all the terms containing L can be deleted. Okay, can be cancelled, and we also cancel out some common constants here, and we rearrange to find uh, m to be this way. Okay, m to be 58 kilograms. And so if the size of the boat is d, okay, and y is the distance moved, that is 0.5 0.4, then we can write this equation as this. Okay, so we can write it as this. So that leads us to a much more elegant solution. Okay, so now the thing is that when the man is here, the center of mass was closer to him. Okay, it is not to the center, not at the center, but closer to the man. Okay, so by a distance x. Okay, so now when the man moves over, the center of mass just flips position, goes to the other side. Okay, goes to the other side and stays at a distance x from it. So what we need to do here is understand that. So if the center of mass has moved by 2x, okay, the boat will move in the opposite direction to keep the center of mass in the same position. Okay, therefore this 2x, okay, will equals 0.4. Okay, so x is 0.2 here. So what we do here is that we take the to find the center of mass, we need to uh, you know we need to account for the contributions of each of these, of the man, the boat, and the girl. So what we can do here is that we can find the moment of the man about the center of mass, the moment of the boat about the center of mass, and the moment of the girl about the center of mass. So the moment of the man about the center of mass is 80 times. So if this distance is d, so this distance is d over 2. And so the distance of the man from the center of mass is d over 2 minus x. Okay, so that's what we have. The distance of, of the point from which the weight acts downwards. Okay, that distance from the center of mass is x. So the contribution of the moment from the boat is 30 times x, so which we have here on the right side, and the contribution, okay, of the girl here is 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 L divided by 2, or sorry, D divided by 2 plus X, okay, times the mass. Okay, so that's what we have here. So we rearrange the terms here, okay, and to find M, and we multiply both sides by 2, and when we do that, so we end up with 80 times d minus 2x minus 30 times 2x, and knowing that 2x is y, we get the same expression that we had before. Okay, so I hope you understand that this particular problem, this involves understanding how the center of mass does not change in the absence of external forces. Okay, so we'll do another problem related to the center of mass in this video. So, so in this particular problem, we have a dog that is sitting on one end of a boat to begin with, and it walks towards the pier, okay, and by a distance of 2.4 meters. Okay, so we want to know, after it has walked a distance of 2.4 meters, what is the distance of the dog from the pier. So now the thing here is that, so the initial distance is 6.1 meters, okay, and if the dog walks by 2.4 meters, we would be tempted to think that the new distance is 6.1 minus 2.4. Okay, but the thing is that the boat is not anchored to the floor of the of the harbor. Okay, it's not anchored. So since the boat is not anchored, the motion of the dog would make the center of mass move this way. Okay, so since there are no external forces, the center of mass does not change position. So therefore the boat moves in the opposite direction. Okay, so it compensates for the movement of the dog. So therefore, we need to do some work to find out how much uh, the, how far the dog is now after it has moved. Okay, so now to find out the position of the center of mass before, we look at x, that's the position of the center of mass. So equals, so 18 kilograms is the mass of the boat, 18 times, okay, and assuming that the center of mass of the boat basically is at the center of the boat. Okay, the center of the boat is at a distance d minus L divided by 2, okay, where d is 6.1 meters. Okay, d is 6.1 meters, okay, plus the dog, the contribution of the dog, it's 4.5 kilograms times d divided by 18 plus 4.5. Okay, so that was before. So afterwards, the same thing here is the, so we have the contribution of the boat as being 18 times d minus L by 2, okay, plus the distance moved by the boat is xb, okay, plus 4.5 times d, okay, minus 2.4, because the dog has moved towards the pier, but it has moved back by distance xb, where xb is the distance moved by the boat, divided by, okay, 18 plus 4.5, okay, and that's afterwards. So since the two positions are equal, okay, 18 times d minus 18 times L divided by 2 plus 4.5 d equals 18 times d minus 18 times L by 2 plus 18 times xb, okay, plus 4.5 d minus 2.4, okay, plus 4.5 times xb. Okay, so xb here, so here the interesting thing here is that that this cancels out. 18, this term cancels out. Okay, so let's see what we have here. Okay, so and so xb, okay, equals 4.5 d, okay, okay, uh, minus 4.5 d minus, so plus 4.5 times 2.4, okay, divided by 22.5. Okay, so that's what it is. So it's basically 4.5 times 2.4 divided by 22.5. Okay, and so the new position, the new distance of the dog uh, from the pier is essentially, uh, so d, that is the new position is d plus uh, xb minus 2.4, okay, is 6.1 plus 4.5 times 22.4 divided by 22.5 minus 2.4, and that gives you 4.2 approximately meters. Okay, so once we, so the trick is to understand that the position of the center of mass does not move. Okay, so we find the position of the center of mass before, the position of the center of mass afterwards, we equate the two, we cancel out the denominators, rearrange the terms, and we come up with xb. Okay, xb is the distance moved by the boat. So therefore here, so the new distance, okay, so new distance of the dog equals this quantity, and that's equal to 4.2 meters. So I hope you can get a flavor for how to use the position of the center of mass to solve these kinds of problems. So if you like this video, click on the like button, and please subscribe to this channel so you can get further updates. Thank you.